All right, so now we're going to do our first practice problem for finding a solution to a linear system. Now, recall that a solution to the system is nothing but an ordered pair. So you have to just graph the lines. Now, we're just giving two equations here. Graph the lines of these two equations here. And once we find the intersection, that is a solution. So I have the steps listed off on the side. Steps to finding the solution of the system of linear equations. I say convert the equations if needed to slope-intercept form. And in this case, we don't have to do that. Graph both lines until they intersect and then check your answer. So we'll make sure we do all of that, okay? So let's go ahead and graph these equations. So again, the good thing is that they're in slope-intercept form. And I'm going to use orange for the first one. Now, -12 tells me that the line, at least there's a point right here, because that is the y-intercept. So remember that. It's the y-intercept. We just did that in the previous slides. So the y-intercept. Not going to try to type a lot. The slope is 3, +3. So when I look at that slope here, I'm going to write it off on the side. That's 3 over 1. Okay, that tells me, and I like to do this in blue, that tells me we can go up towards the sky, and then we can also run to the right because that's positive. Or it's going to go down to the left. Okay, because think about it, when it goes down and it goes to the left, those are both negative directions with two negatives that make a +3. Okay, and up and right is positive direction of a line. So let's go ahead and graph this. Let's count. We're going to go up 1, 2, 3, and then we're going to go to the right 1. I'm going to put the little point right here. 1 spacer 1, 2, 3. Yep. So let's do it again. We're going to go 1, 2, 3, and we're going to go to the right 1. So let's do it. 1, 2, 3, to the right 1. Make sure I put my point there. Let's go 1, 2, 3. And let's also put a point right here. And I think that should be good enough. You can continue if you need to, but I think this should be good enough. I'm going to go ahead and draw. Let's get this. See if we can do a black line. Just so we can see the orange points. Okay, wasn't too bad. I'm going to go ahead and erase the green and blue as good as I can. Clean it up a little bit. All right, let me leave it alone. Okay, so now we're going to graph the second equation. Now the second equation, we have y equals -2x plus 3. Y equals -2x plus 3. I'm going to do this in red. So let me go ahead and erase this real fast. So again, you have your y-intercept. This is where you start. I always say start here. So that's +3. That's up here. Now my slope is -2 over 1. This is my slope. Okay. Remember, this is the m. So this is going down. We have a negative direction here. So we're going to go down. So we're falling from the sky in this case. We're going to go down. And then we're going to run 1. So we're still running this way. Or we're going to go left and go up. Okay. Now, in this case, given the scale of the graph, we're going to go down. So let's count. If I'm at 3, I'm going 1, 2. Okay, I have to be careful with this. And then run to the right 1. Okay. 1, 2. And then to the right 1. 1, 2. It looks like we have an intersection. And then to the right 1. we're going to go 1, 2, and then to the right one. I think it's safe to stop there. I'm going to go ahead and put a point here. We have a point here. We have a point here. We have a point here. Try to clean it up a little bit. So the intersection is obviously here, right? We have an intersection. So this is the intersection. So this would be our solution. I'm going to try to type that in for you. All right, so this is where we had an intersection. Look like it adjusted there. So in this case, the intersection is, let's see, 1, 2, 3, 1, 2, 3. So 3, negative 3, 3, negative 3. So I'm going to go ahead and type that in to here. Look like it's 3, negative 3. And what do we need to do? We need to check. We need to check the answer there to make sure that it's 3, negative 3. So plug these in, and if it holds, then if it's true, then it is indeed the solution. So let's go ahead and try it. So I'm going to check my work here. Say, let's check. Okay. So I'm going to check this one. It says y is negative 3. So say negative 3 equals 3 times 3, which equals, minus 12. Kind of bad. Let me redo that for you guys. Try to type it. 3 equals, so much better. 3 times negative 3 equals 3 times 3 minus 12. And that's indeed true, right? Because we know that negative 3 equals 9 minus 12. Okay? So that's negative 3 equals negative 3. So that's true. Okay? So that holds true. So the same thing has to happen for this. And I'll try to do it under here. So again, this is our x. And we have our y. Okay? So our x is 3. So, and our y is negative 3. So this will be negative 3 equals negative 2 times 3 plus 3. And again, I decided to not type that for some reason. So bear with me with that, please. I'm going to go ahead and type that. So that says negative 3 equals negative 2 times 3 plus 3. Okay? It's a little better there. Let's see if this holds true. And it does. So you have negative 6 plus 3 equals negative 3. So yes, that means that negative 3 equals negative 3. So this is indeed a solution. 3 comma negative 3 is a solution to the systems of linear equations.